Unit 3, Part 8 notes, I can solve an absolute value inequality. Reminder of our absolute value definition, it is the number's distance from 0 on the number line. So remember, when we're working with distance, that value is always going to be positive. So the absolute value of 5 is positive 5, because 5 is 5 units from 0. And the absolute value of negative 5 is also positive 5, because negative 5 is also 5 units away from 0. So now we're going to think about this concept with inequalities instead of equal signs. So last lesson we talked about the absolute value of x is equal to 3. So if we thought about that piece, the absolute value of x is equal to 3, which remember that's asking what number is 3 units away from 0. So if I go 3 units away from 0, I get 3. And I also get negative 3. So if I jump 3 to the left or 3 to the right, that's where I end up. So I'm going to put 2 circles there. And then if we go back to this inequality piece, it says less than 3. So which pieces would have an absolute value of less than 3? Well, 2 would have an absolute value of less than 3 because 2 is only 2 jumps away from 0. 1 would also have an absolute value because it's only 1 jump from 0. Same with those negative 2 and negative 1. So when we do a less than inequality, we're going to have an and compound inequality. So if we think back to Unit 3, Part 6, we talked about compound inequalities. So this one is one of those and compound inequalities because it's going to be those 2 values and then anything in between. Now in the opposite case, we have the absolute value of x is greater than 4. So if we think about, we have 4 has an absolute value of 4. Negative 4 has an absolute value of 4. Well, we want anything that has an absolute value that's greater than 4. So 5 would have an absolute value that's greater than 4 because 5 is 5 jumps from 0. Same as 6, 7. Those would all be greater than. So what we can do is we can shade those numbers and make that inequality graph. And then we would also shade the opposite over here because all of those negative values would also have an absolute value that is greater than 4. Because if I just pick a random number, negative 9, the absolute value of negative 9 is greater than 4. Well, what's the absolute value of negative 9? Negative 9 is 9 jumps from 0. 9 is greater than 4. That is a true statement. So whenever we have a greater than inequality, when we're dealing with absolute values, it'll be an or compound inequality. It'll have that or graph. So we are going to solve some absolute value inequalities. Now, very similar to our equations, we're still going to have that positive and negative case. So we can split this up into x take away 2, that piece inside the absolute value bars, is less than 7. That's our positive case. Now with our negative case, we are going to have one change. We're still going to do x minus 2, and we're still going to make that 7 negative. However, now that we're dealing with an inequality, we're going to have to flip that inequality. Instead of being less than 7, we're going to make that greater than. So greater than negative 7. So that's the one change here. So we still solve these like normal. Undo that minus 2 with a plus 2 on both sides. We get x is less than 7 plus 2 is 9. X is less than 9 is one of our answers. We do the same thing on the other side. We undo that minus 2 with a plus 2. And we get x is greater than negative 7 plus 2 is negative 5. So now we can graph this. We have 9 and negative 5 on our number line. No real great way to get that on our graph, so I'm just going to kind of estimate where pieces are. I like to put 0 on there just so I know where 0 is between my numbers. It can be helpful. So if we have x is less than 9, that's going to be an open circle at 9. 0 is less than 9, so I'm going to shade towards 0. And then x is greater than -5. It's an open circle at -5. 0 and 9 are greater than -5, so I'm going to shade towards that. And you can see that we have that in-between graph, which makes it an and compound inequality. We also began with a less than symbol, which if we remember back to that last slide that we just did, if you start with a less than symbol, it's always going to be an and compound inequality. So if I look over at my next example, I have the absolute value of -3x is greater than 12. So right now, I know greater than is going to give me an or compound inequality. So I can just put or right down there in that circle. And then I can now do my positive case and my negative case. So I have -3x is greater than 12. So that positive case really just gets rid of those absolute value bars. Then my negative case, I'm going to do -3x. I'm going to flip that inequality sign to less than, and I'm going to make that +12 -12. Now I'm going to solve both of these equations. -3x is multiplication, so I'm going to undo that by dividing by -3. Divide by -3. And we get x is less than, I do have to flip that inequality because I divided by a negative. 12 divided by -3 is -4. So x is less than -4, or when we solve this other side, we'll get our other piece. We do the same solving process, divide by -3. So x is, again, we have to flip that inequality because we divided by a negative. -12 divided by -3 is +4. So we have x is less than -4, or x is greater than 4. So I'm going to count by 2's here to make that fit nicely. And then I'm going to graph these. I have an open circle at -4, an open circle at 4, and then shading in that opposite direction because it's that or compound inequality. All right, for this third example, we have the absolute value of -2x take away 3 is greater than 7. I'm starting with a greater than symbol, so I know I'm going to have an or compound inequality. So now we set up our positive case and our negative case. We have -2x take away 3 is greater than 7. Our negative case would be -2x take away 3. We're going to flip that greater than to less than and make that +7, -7. And then we are going to solve this. So I want you to try to solve this, graph this, try this problem on your own, pause the video, and then when you play it, you'll see the answer and you can see how you did. All right, so here's the answer that you can see. One thing I really want to note is that make sure, since we divided by a negative here, we did flip the inequality. So it went from greater than to less than on this side, and it went from less than to greater than on this side. All right, we'll go through this last example together. We have the absolute value of 2x plus 5 on the outside of that absolute value bar is less than or equal to 19. So the first thing we have to do is make sure we only have the absolute value bar on the one side. So this plus 5 that's not inside the absolute value bar has to be undone first. So we are going to subtract 5 from both sides. 5 take away 5 is 0. We're left with the absolute value of 2x is less than or equal to 19 take away 5 is 14. So now we can do our positive negative case. We have 2x is less than or equal to 14. And then our negative case would be 2x. We flip it to greater than, keep the equal to piece. So we're just flipping the sign. And then not positive 14, but negative 14. We started with a less than symbol, so it's going to be an and inequality. And now we can solve for x. Undo the times 2 with divide by 2, and we get x is less than or equal to 7. 14 divided by 2 is 7. And then in our negative case, we divide by 2 on both sides, and we get x is greater than or equal to negative 7. So we have x is less than or equal to 7, and x is greater than or equal to negative 7. So to do that, we'll have closed circles at both negative 7 and positive 7, and then it's an and, so we shade between those two values. That is all your notes for this assignment. One thing I want to show you is in your practice, you can do the work on a separate sheet of paper if that's easier. However, if you do decide to type it up, or if you want to use like the writing tool, I do have these and ors that you can just drag. So if we're thinking this is a less than that we were given, this one would be an and then you can drag the or over here because we started with a greater than symbol. And then I do have the circles that you can just drag and drop into the graph. So however you find it best. Otherwise, you are always welcome to just take the problems that you see on the screen and do the work on a separate sheet of paper. I know that doing math on a digital version can be a little difficult. So whatever you find best, please utilize whatever tools are easier for you. If you have any questions, please reach out. Otherwise, go ahead and complete your practice.